So, I'm Daniel, and I hate money. And because I hate money, I chose the hobbies of photography and cars. So, two things, just... And because I really, really hate money, I bought a flying camera. So earlier this year, bought this thing because we were going on holiday, and I've always wanted to take, like my entire life, I've wanted to take a photo of my car, like driving in the French Alps. And we were driving to the French Alps. So I thought, let's spend a ton of money on this. So went to France, took some cool pictures with my flying camera. Because I like, you know, the idea of like expressing motion in static pictures. So this is, we spent like a couple of days. This is my wife driving, so she spent 2 hours just driving up and down this piece of road while I'm flying this stupid thing around. But we got some really nice pictures. Now this kind of photo is easy. The camera is static, the thing's moving, you turn the shutter speed up, no problem. This kind of picture, not so much. So you have to have your flying camera moving on the same 3D vector at the same speed as the car. This picture was taken at about 40, 50 kilometers an hour. There were some near misses maybe, but otherwise not so bad. So the result of this was the best thing. Social media likes. The currency of the world these days. So this is in France. The laws in France about drone photography are the same as most of the world. You know, don't fly over people. If you fly over roads, make sure there are roads where there's no cars except your own. Things like that. Make sure you have the permission of everybody in the shot, yada yada. That's my wife, it's fine. So I thought, okay, cool. Let's bring this to Sweden. So the Swedish laws for drone photography are significantly more stringent than most of the rest of the world. And for every single photo you take from the air, and there is probably some definition of what from the air is. So if you fly at this level and take a picture, and then with your phone, it's probably okay. But you have to submit your photo to this agency called, here we go, my Swedish is terrible, Lantmäteriet. No, that wasn't right. Close enough. That place. So you need to give every single picture, you need to upload it to these people, and you need to give it the image coordinates, the street address, the commune, and the, another long Swedish word, fastighetsbeteckning for the location. Thank you very much. And this is kind of like a property designation, I suppose. It's not the street address, but it's kind of like it. It's like a word, a number, a colon, and then another number. And the problem is, so image coordinates are built into the image, right? No problem. Street address, you can do a lookup fairly easily. Commune is usually part of the street address if you're using like Google image coordinate to address lookup APIs. But this guy is not an international thing, it's a Swedish thing. So these people have a map you can scroll around, and you can click on the map and it will tell you the fastighetsbeteckning of the place you click. So for 25 images or so, it took me about 45 minutes to build my submission to these guys for approval. So this photograph here has had a person in the government somewhere look at it and go, yeah, there's no national secrets in that. Okay. 45 minutes for 20 photos is way too much time, but I did it, and I was like, okay, never doing that again. So I present to you, see, I took all the Swedish letters out, Lantmäteriet lookup. And it's a small command line app written in Swift that extracts the image geotag. You give it some images using the image.io framework that's built into the macOS. It will reverse geocode that coordinate into an address using the core location APIs that do that. So it will convert the coordinate to a thing called SWIREF. So GPS and all of the sort of internationally compatible location APIs tend to use a thing called WGS84, which is one international standard for expressing coordinates. Lantmäteriet, because they're Swedish government, they must use a Sweden-specific coordinate system. And because it is the Swedish-specific coordinate system, it is the best coordinate system in the world. We should be hearing the Swedish national anthem now, but never mind. So anyway, so it converts the coordinate to SWIREF. It performs a a lookup via an API that I found by clicking around the map and watching the developer tools thing, so it's probably not public, but it is now, API. And finally, we put a table out to wherever, and then you can copy that and paste it into your manual submission to this thing. So I'm kind of rate limiting the lookups because Apple give a very, very vague, don't be too mean or you'll get rate limited documentation on this, but it's 1 second per image. So 20 images is 20 seconds instead of 45 minutes. So this saves a bunch of time. So I'm going to talk a little bit about that process. So I wrote the command line app in Swift, and I started using the Swift package manager, which is kind of been on the periphery of Swift for quite a long time. Like I imagine a lot of people have kind of heard about it, but maybe you haven't used it, because it isn't really suitable for iOS apps yet. But still, it's a fun little tool. It was nice, so I'm just going to talk about that a little bit. So first, of course, we make a new project, so we go to Xcode. No! We do not go to Xcode. So the Swift package manager is compatible with Mac, Linux, probably Windows. Now, Linux doesn't have Xcode, so that means that the Swift package manager, Xcode is optional. So we actually start on the command line. So we make a folder called test. We do Swift package init, and you give it a type. The types are executable, which is a normal executable, library, which is the framework, system module, I have no idea, and empty, which is an empty project. What this will do, it will create a kind of a directory structure for you, and importantly, it will make a file that I forgot to write the name of here called package.swift. And package.swift is a definition of your product or products, your apps. And the interesting part here is dependencies. So the Swift package manager works not unlike CocoaPods or Carthage in that it is a dependency manager. So I didn't include the full URL here because it's this long, but my lookup tool depends on the Swift package manager itself, and I'll explain that in a second. And it has one target, and its name is that, and the dependency utility is actually served by this. And then you do Swift package update, and that will resolve the dependencies and download them for you and put them in the right place. Swift build, it will generate a binary and a very long subdirectory name, and then you can run it, and there you go. You've created a binary in Swift without Xcode. And unlike app deployments, the Swift standard libraries are statically linked into this binary, so you can distribute only the binary on its own and it will run. Where apps and whatnot, you need the dynamic libraries in there as well. So this binary is portable onto the target you've compiled it for. But we do want to use Xcode because it's kind of nice. You can type stuff and it sometimes doesn't crash. It's great. So you can type in Swift package generate Xcode proj, and it will generate an Xcode project for you. And it will look like this when you open it. So your source files go in this directory, and with the Swift package manager, the directory structure is important. It makes some tests for you, which you'll find here. It will. I made this screenshot too soon, but if you have dependencies, there'll be a folder called dependencies, and they'll all be in there as well. And you can run it like a normal project. It will put your output here, and it's super nice. So you're like, oh yeah, Xcode project, yeah, let's add it to our Git. No, you cannot add the Xcode project to your repository, because right now your dependencies go into this folder here, and you'll see this number. Whenever you make a new Swift update on your machine, it will stay the same. So you're like, oh, it stays the same, great. But when you go to a new machine, that is a different number. And then if you have your Xcode project checked in, it will no longer work. So you maybe put it in your git ignore, because it's super easy just to generate a new one. It'll put, if you've done more than one source file, it'll put them all in there. It's super nice. But to be honest, if you're just making a little command line app, all of this is optional because you don't really have to compile. So if you put a hashbang which is this thing at the top of a Swift file, hash, pound, wherever you're from, exclamation mark, user bin Swift. You can just run the Swift file if you mark it as executable as any other script, like a Python script or a Bash script. So you can just do that. This method does make it harder to import other Swift files and frameworks and dependencies and things. But if you just got a few lines that you want to do, you don't even have to compile. Like, you need no tools. So a couple of little tips. So if you are using your Xcode project and you want to have command line arguments, which you tend to do for a command line project, you can edit the scheme in Xcode. So you click the name of your thing at the top left, go edit scheme, and you can just add them here. So every time you hit run in Xcode, it will pass those command line arguments to the app. And this is the case for anything, like iOS apps, Mac apps, anything. Now, the Swift package manager itself, if you depend on it and then sort of add it as a package dependency and then depend on utility from it, it has a really nice command line argument parser, an open source one that works on all of the Swift platforms built in. It's very Swifty, it's strongly typed, it's really nice. So you can create in your code, you make a new argument parser, and you add arguments to it. So this is my verbose one, and we want a Boolean and some things like that. And I can make an array of my arguments, I could parse them, and then just pull them out. And it's really nice. And it will do the help text for you. So it will take this usage text and this overview text and this usage text here. If you do like my command line -h for help, it will print out a really nice sort of explanation and a documentation of all the command line arguments. And this is just the code you need to do it. You don't need to build that yourself. Okay, so that's nice to get us started. Another interesting thing in scripts like this is concurrency. So unlike an iOS app or a Mac app, when you start to run a command line program like this, either with a compile binary or as the script thing, it runs from top to bottom and then exits. It is synchronous. As soon as you run out at the bottom or you return from your main function, you're done. It's exited. So if you do asynchronous work, that's a problem, because as soon as you can spin up a background thread, no problem. But if you do that, you just use dispatch async, like here. Typically, you'll exit before your work is done, or even starts. And a very typical way around this is using a lock. So we create a lock here, an NS condition lock in this case. We execute this, and then we call lock.lock when condition 1. And this will halt the main, it's the main thread, if you like. And then this will run, we sleep, very busy work. And then we can unlock. And when we unlock here, this will return, and then it will carry on. So that's a way of basically making asynchronous work synchronous. Now, a problem comes when you don't have a choice on your asynchronous work. So if we do some async work on the main queue thread, can anybody spot the bug here? So this is a deadlock. So we create a lock, and then we execute this, and then we lock here. So this locks the main thread. It is halted. But we're trying to do some work on the main thread. But because the main thread is halted, this can never execute. So we can never unlock the lock. So we're in a deadlock, and you're done. That's it. Like this is halted, and this will never execute. So, I mean, the answer to this is to, when you can, make sure you're on a background thread, but sometimes you don't have a choice. So this is the core location Geo Coder Api that the command line app I wrote uses to look up addresses from coordinates. And this is the API. You make a Geo Coder, and you call the API, and you get an asynchronous callback back when it's done, because it's a network request. But the problem is you can't tell it what queue to call back on, and it calls back on the main queue. So how do we do this? Because we can't tell it, where to do its background work. Now, what we can do is we can taking advantage of the fact that while threads and core, oh my God, what's it called? Grand Central Dispatch, thank you. Threads, Grand Central Dispatch queues, and run loops are different abstractions of asynchronicity. It is a fact of the way programs are run that the main thread and the main queue and the main run loop all run on the same thread, the main thread. And they are functionally, I'm not going to say the same, but kind of effectively they are. So what we can do is take advantage of CF run loop. And CF run loop is a thing that powers every single iOS and Mac app there is. And a run loop is a tight loop that has things attached to it that execute on each execution of the loop. And that is the main run loop is the reason your iOS or Mac app doesn't immediately exit when you launch it. So it will attach event handlers to it. So when touches or mouse clicks or whatever come in, they will go into the run loop and then they get to be handled and then your code will be called and so on. And this is how a modern app works. So it is a tightly run synchronous loop that we can attach things into to execute. And we can take advantage of this. So this is the core location lookup code again. What we do this, we execute this, and then we call CF run loop run. And because we're just running a main, on the main thread, we're just running some code and then exiting, this is the main run loop. And when you call run, this acts, it doesn't act like a lock, but it does the same thing in that this doesn't return. It will run the run loop. And when you run the run loop, it doesn't, what word am I looking for? This blocks, right. So the run loop is running and running and running, and this is blocked. So we're halted here. However, when you dispatch async to the main queue, that gets inserted into the main run loop. So this block, when it gets called back, will be inserted into the main run loop and it can execute on the main thread. So we set the result and then we call CF run loop stop. And that will stop the run loop. This will return and you carry it on. So functionally, in this example, it works exactly like a lock, even though it isn't a lock. So that is how, because these days everything is asynchronous, right? It's the way to do things. You can't even do a network request synchronously anymore without being shouted at by Xcode and everybody here. So this is kind of a way to, if you really want to make just a simple little script, you have asynchronous APIs, you can kind of make them synchronous with this kind of thing. So yeah, and this is actually a very short little punchy talk, but so these are the tips I use to make my little command line app in Swift. I'm quite pleased with it. So because I did this and sent all these pictures off to the government agency and they looked at them, I'm going to make you look at them as well. So, whoops, too far. So this is near where I live. It's just sort of southwest of here in Botkyrka. It's very nice, just as the autumn was coming in. Some nice orange on the trees there, very beautiful. This is Mälaren, so again, southwest of where we are. Autumn's a bit coming in more. The nice thing about an aerial camera is you can see through the surface of the water, so we've got a nice rock here with the current of the lake sort of dredging up some mud. This is a fun pattern I saw in a field. That's me. And here is a misty sunrise above where I live. So we live in a really beautiful country. I know like Stockholmers seem to think there's no countryside. I sometimes get asked if my SL card goes far enough for me to get home, but we live very close to some very beautiful things. Okay, this is me. I'm iCanDuck everywhere. That's my blog where I'll put more pictures on. And if you want to look at the code I was actually talking about, it's on GitHub here. And I did a blog post about it as well. So I have no idea if there's time for questions, but thank you very much.